In this video, I'll be discussing depth of field. Depth of field is basically referring to the portion of a scene that appears sharp or in focus. Other objects in the scene are blurred based on their distance from the focal point. The farther they are away from the focal point, the more blurred they become. In the world of photography, depth of field is determined by the subject's distance from the focal point, things like the camera lens focal length and the camera lens's f-stop value. Depth of field is primarily determined by the lens f-stop value and, of course, the subject distance from the camera. To determine what depth of field is and how to use it, I've prepared this basic test scene. And in the test scene, what I've done is just created some text objects here that display the length from this camera. And they vary from 6 inches away, I believe the last one's 76 inches away from the camera here. And what I'll do is just go ahead and run a base rendering here with no depth of field, just to give you an idea of what it looks like. And I'll pause the video while this renders. It's not going to take long, but I'll go ahead and pause the video. Now, as you can see from the render here, everything is pretty much in focus. Everything has the same amount of focus. There's no depth of field applied to this image. So what do we need to do to enable depth of field? Well, that will depend on the render that you're using. If you're using something like V-Ray, they all have basically the same functionality, but how you get to it is going to be just subtle differences between each. For this particular video, I'll be using Mental Ray. The scanline render that comes with 3D Studio Max also is capable of depth of field, but I prefer to use Mental Ray for this discussion because generally the results that you'll get are closer to real-world settings in Mental Ray or V-Ray or things like that than with the scanline renderer. So again, I'll be using Mental Ray, and I have this set up with Mental Ray as my production renderer here. And I'm using there's no final gather. It's just I have an image precision of 1 in 16, and to enable depth of field here for the image, what I'll do is just click on my camera, select my camera, and scroll down to this multi-pass effect area of the camera. Now, by default, it's set up for this depth of field option, which if you enable that, it's not going to work with Mental Ray. This is for the scanline renderer. So if you're using scanline, you'll want to use this default option here for depth of field. But I'm using Mental Ray, so I'm going to switch to depth of field Mental Ray. And of course, you have to enable this option, so I'll just highlight enable. And right now, it's using a target distance of 6 inches. So what that means is the depth of field uses this target distance. So my focal point is this 6-inch text object here. So in addition to the distance from the camera, as you can see, I have Maxwell installed, and you have this other option here for Maxwell if you're using that. I'm just going to roll that option up. But getting back to Mental Ray, it uses the target distance, but also it's using this f-stop value. If you remember in the intro to the video, I said that its depth of field is really based on the distance, your target distance, as well as the f-stop value. So here you can see how that relates to real-world settings. Right now, the default value is an f-stop value of 2. I'm going to leave that as is and just go ahead and give this a test render. And now, as you can see, we have a strong depth of field effect going on where we're in focus 6 inches away from the camera, or basically in focus 6 inches from the camera itself, and it gradually blurs objects more so as they increase in distance away from our camera. You'll also notice that there's quite a bit of grain. It's not a smooth effect. It's starting to smooth out those that grain effect that you'll get with such strong depth of field. The problem with that is that this render, the original, or the first render, was about 1 minute and 50 seconds, I believe. It was under 2 minutes. Whereas when I used the higher sampling rates, you can see that the render time went to almost 6.5 minutes. So you do take quite a substantial hit in render time when you're using strong depth of field and need to smooth out that effect. That being said, this default value of 2.0 for the f-stop is, as you can see, really strong. It depends on the look that you're after, and of course the size of the objects and things like that that you're going for here, but for my taste in this particular scene, that's really strong. And the f-stop number here is basically referring to, in the camera world again, or speaking of a camera lens, it's referring to the aperture of the lens or opening of the lens. Lower values here, like a low f-stop number, say like 1.4 or 2, is going to simulate that lens being open more, and so you get the stronger effect. Whereas if I use a higher value, let's just say f8, the lens or this depth of field effect will be a little bit softer. It won't be as strong as you see here. So the only thing that I've changed, I'm not worrying about the target distance. The target distance is the same. I've just increased this f-stop number to 8, and I'll go ahead and bump that back down to 1 in 16 so I don't have to wait so long for the render, and give this a render. So now, as you can see, the effect isn't as pronounced as it was with an f-stop of 2.0. Also, my render times went down substantially, just because it's not having to blur as much as it did with that low f-stop value. So there you can see the effect that f-stop has on this. Now let's look at the target distance. If I wanted to move that target distance somewhere, maybe let's try 46 inches away. What that's going to do is it's going to gradually blur up to that 46 and then gradually blur away from the 46. So I'll just leave the camera settings at 8, I believe it was, f-stop of 8, and with a target distance of 46 inches, and give that a render. So now at 46 inches away from the camera, you can see that that's in clear sharp focus here, and then coming towards the camera up to 6 inches away, it gradually blurs objects more. It also blurs objects more as they get farther away behind this 46-inch mark. The 76 is, as you can see, a little bit blur. So with this basic setup, you get an idea of how the target distance and the f-stop numbers work together. Again, if I decrease this back to the default of 2.0, you're going to see these blow out more. The 46 will stay in focus, but these will be the ones that are out of focus will just have more of that depth of field effect on them. Okay, so obviously looking at this example, as you can probably imagine by now, I need more samples here. So what I'll do is increase the sampling, and as you know, going to 4 and 64 isn't really going to completely resolve this. So what I'll do is increase that to 1024 and 64 for the minimum, and let that render, because that's the maximum that the maximum value there that we can use. So I went ahead and canceled that render just because it was taking so long to finish, because you can get an idea of how that's smoothed out now with the very high settings here that I used. So really, I would say that is the main drawback to actually rendering depth of field, is the speed hit that you'll take on your renders by doing that. Another drawback is also related to speed. For example, if you render this out and then somebody, maybe a client, says, well, I don't like that, I'd like for this to be a little more in focus, you're going to have to go back and re-render the thing, and then if it takes a long time to render, then you're that much farther behind on the project. So there are other options apart from rendering depth of field. So I'll just hit, in this camera view, I hit P to change to perspective, and let's go back to the settings here. And as you can see in the depth of field perspective option here, you can switch to between f-stop and in focus limits, and you get different values here. F-stop is similar to our camera, where you have a focal distance, if you will, focus plane, and the f-stop number. So if I change this to, let's set that to 8.0, and let's say 46 inches from the camera, we should get a similar result to what the render we had a while ago, where I was looking through the camera and set those values up the same. And that looks about the same as the previous render with the same settings on our camera. The issue with this is, what if I did not have a camera in my scene? Let me just hide this. Now, how do you know you're in a perspective view? How do you know the distance that you are from that 6 inches away or 46 inches? And the answer is you don't. So that's kind of a drawback, and one of the reasons that I rarely ever use this perspective view option is because it's really hard to control, because you don't know where you are in space out here to kind of dial in these settings. And again, there's two options here if that's something that you would like to use. You have the in focus limits, where you basically set up you have a near focus, a focal plane, and a far focus. So what you would do is leave that at 46, and if you were supposedly 46 inches away from there, somewhere in here, that 46 would still be in focus, and it would be start blurring. But basically, I wouldn't recommend using this one, because again, it's very hard to dial these numbers in, because you don't know where you're located when you're looking through a perspective view. You don't know how far you are away from your objects. Now with mental ray, you have even more options than just those two for doing depth of field. Another option is, let me just disable this, you have these camera shaders here. Well, there's a lens shader, this architectural depth of field and bokeh shader, that you can add to your scene to do depth of field. And as with these camera shaders, all that you need to do to dial this in and make it work with your scene is, of course, assign it to the lens shader here, but then you'll also want to drag it as an instance copy over to the material editor, so that you can make some changes and set this up however you want it. So what I'll do is just unhide my camera here and switch back to the camera view. And let's take a look at this without having to increase the samples across the entire image. You can increase the samples only on the depth of field effect here. Some of the other stuff here I'll get into in just a second. The blade count and this bokeh map, which is one of the neat features of using this. So what I'll do is just go ahead and give this a test render. And as you can see, we get a depth of field effect. Now if I want to decrease that effect, what I'll do is to make this less pronounced is, instead of changing the distance, I'll just decrease the radius of confusion. Let's just say 0.25. And what that will do is make this less pronounced. We basically set up that architectural DOF and bokeh shader. One of the really neat functions of this architectural depth of field and bokeh shader is the ability to recreate bokeh effects. A bokeh effect is on your camera. If you take a picture of something and it's in strong depth of field and it's a strong highlight or maybe a light source, what you'll get is you'll see the actual shape of the aperture or the shutter, the blades in your lens as they open. I think it would be called the diaphragm, if you will, of your lens. And so these highlights will take on the shape of that. If you go to Wikipedia, they have a good example under bokeh. Here you can see how you're picking up the shape of that opening on your lens. So that's one of the neat features of this depth of field camera shader, is that it will recreate that. And so what I have is, let me just load up a scene that I made for that. because it's flat text, doesn't really show the highlights like something rounded would. So what I have is just a couple of torus knots here that have a chrome material applied to it. And if I just give that a quick render, you'll see that again, it's just a basic chrome material with an HDR environment, which will give us some nice strong reflections here that should work well with the bokeh effect. So what I'll do is, I think I've already assigned it here. Yeah, just enable the lens effect, and I've assigned this architectural depth of field and bokeh shader. This may actually be hidden by default. If you go in and you don't see it listed here, it's because it's hidden in the production shaders. I'll make a separate video on going over how to unlock and unhide shaders and install plugins and things like that. So if you need to know how to do that, there'll be a separate video on unlocking and unhiding some of these shaders. But all you do is add it to the lens shader and then drag it over as an instant copy to your material editor so that you can go in and make these changes. What I've done is it's set up for 72 inches, which I believe is the distance to this first object here. I've got a strong radius of confusion, which means it's going to be a strong depth of field to provide a lot of blurring. Fairly high samples at 64, just because I want to be able to see a little more detail in here. Now what I've done is, I'll tell you what, let's just go ahead and give this a render without using the blade count or this bokeh map and see what we get. Okay, and what I'll do now is go ahead and add this into the RAM player here so that we can compare the results that I'll get from the next render. You can see how these highlights are basically round, or the strong reflections here are round. So what I'll do is to define a blade count number here, and I'll just put in, I'll just say 5 so it's fairly evident. And the blade angle will actually rotate that. I'm just going to leave it at 0 right now, and go ahead and give this a render. Alright, I'll go ahead and put this in the RAM player. And as you can see the difference, we now have, you can see these, I've set it up for 5, a blade count of 5, and you can see the 5-sided highlights that we get, similar to this bokeh example. And so that's one of the neat features that the regular depth of field, like the camera depth of field or the perspective depth of field in Mental Ray, doesn't offer this, but you can make that happen using this architectural depth of field and bokeh camera lens shader. Another option here is, as I said, you can use a custom bokeh map. Let me just close this RAM player, and what that'll do is let me assign a bitmap that I can create to this shader. And here's a couple that I've made. Whereas before I assigned a 5-sided blade here to the shader, you can create the same thing with by just creating a small black and white image for different shapes that you may want to try, and create some neat looking highlights or reflections where it gets into that depth of field. You can also make them color like these red, green, and blue examples that I have here, and it'll give you kind of a chromatic aberration effect. So if you want to render depth of field effects, so again, some of the drawbacks of rendering the depth of field effect is, of course, the speed hit that you're going to take on your renders, and if you need to make changes, you know, it's kind of hard to do those without having to re-render and set through that render time. So one of the other things that people would do is do the depth of field, create the depth of field in post, and to do that I'm going to go back to this first scene that I had, and what I'll do is set this up with a render element. Go to render elements, and I'm going to add a z-depth render element, And in the render element, you'll find the settings are similar to the depth of field settings. You have a minimum and a maximum range. And for the minimum here, 300 inches is obviously out of range because we're only going up to 76 away from our camera here. So I'm going to set the maximum range to, let's say, 66 inches. And the minimum, let's make that 12. And I'll give this a render. And as the render completes, what's going to happen is it's going to pop up a render element. It'll be a separate frame buffer that will appear, and we can use that to create the depth of field in a post application. Okay, so as you can see, I have a different render frame buffer here, and so what I'll do is save this out. I'm just going to save it as a JPEG right for now. And I'll save our diffuse map, or our diffuse render. Okay, and what I've done, I've opened up the images here in Photoshop, and what I'll do is just select all of this one of the Z-depth pass and copy, just minimize that, and then in the channels of the diffuse map here, or diffuse render, I keep calling it a map, I'm going to create a new layer and paste the Z-depth render into there, and I'll just leave that as is. And what you can do is go to filter and distort, and I believe it's under lens correction, and I'm wrong there. You can tell I don't use that too often, but actually it's under the blur filter. You have a lens blur effect. And what it's going to do is you can select your source, which in this case I'm using alpha 1, which is that Z-depth option that, or Z-depth render that I put in there. And you can increase the blurring effect. As you can see, this taking effect here as I increase this. Let me just turn it on faster. But that's one way that you can do depth of field kind of in post. And again, here you can see the shape. There's a hexagon. That's also simulating the bokeh, or those blade effects you can get. So I tried to recreate one using that camera data with a model that I have. And well, what I have here, if you look at this photograph, you can kind of see how the focal point here is on this wheel, and you can see the depth of field getting stronger off in the distance on this Corvette photograph. Well, the photographer, if you look here under more properties, let me just open this in a new tab, you can see the information such as the aperture. There's that F number that we'll need, the focal length for the lens, exposure settings here. So there's a lot of information, real world data that you can get from sites like Flickr, that you can set up your 3D scenes to kind of match these, if provided your models and everything are to scale. So let me just open up the scene that I have for this. Still trying to get used to this new way of opening files in 2010. There we go. Okay, so I had a similar Corvette model to this particular photograph that I'd had for a while. So what I did was just went through and set it up, and you can see there's just a basic, I have a ground plane to kind of match the look there, and then I put in a camera. Let me go to another view. There's the camera. Let me go back into my camera view. And as provided by that EXIF data, let me just try to pull this over. you can see that I have a lens which is 70 millimeters to match that focal length here of the lens. Aperture is f8. Let me scroll down. You can see that I have f8 for the f-stop value. And I've also set up the my exposure settings in a similar setup as what they have. Just bring that back. You can see I have an ISO speed of 200, and here there's an ISO speed of 200. That's not really important to know for the depth of field, because in mental ray here in this particular setup it doesn't take that into consideration. I was just showing that you can use the same values for your exposure control if you can find them located in this EXIF data, and set up the scene in a similar time of day, etc., that you can get a similar result. So what I have again is the same data here from my f-stop. The target distance, naturally I had to kind of guess at, but I have the target distance set to 55 inches, which from that lens is on that front tire right about here in that center cap. So if I give this just a quick render, we'll see how close I can get to the look of that depth of field in that photograph. And naturally, keep in mind, it's not going to be a perfect match as far as colors and things like that. I'm mainly focused on getting that depth of field, see how close I can get using the same settings. So I'll just give this a render. Okay, I'm going to go ahead and stop that render because I think you can go ahead and get a feel for the look of the depth of field in this image. And again, here is the photograph that I'm trying to mimic using the same settings from the EXIF data, with an f-stop of 8.0 and a 70 millimeter lens on the camera. And you can see how I get a very similar amount of depth of field, because again, I'm using the vehicle here is realistically scaled in proportion to the actual model here, and very similar results that you can get when you're using realistic scale values and realistic real world f-stop values and camera lens information. On the flip side of things, you can also have realistically scaled objects and just start plugging in depth of field information and come up with some incorrect results. I've set up a scene here that you can see where even though the vehicles are realistically scaled, they look like miniature models because the depth of field is set up incorrectly. So you may see that often where it's set up wrong, or if you go in and you're just kind of guessing at the values to plug in. You may actually make a full-size model look like a miniature model. So do be careful when using depth of field that you try to mimic real-world objects and settings to get the best results. Now, I do highly recommend going around here at Flickr, things like that, and actually go through the images and kind of get some real-world examples that you can recreate to get a feel for using the depth of field. So I do recommend going through, especially if you don't have a photographic background. If you're not familiar with photography or things like that, you may want to spend some time going through those settings. So I do highly recommend that. And so with that, that concludes the discussion on depth of field, and hope it's helped out and that you picked up some tips there.